The last type of ionic compound we're going to talk about is an ionic compound that consists of a multivalent metal. Now, a multivalent metal is simply one that is within the intertransition or transition metals on the periodic table. So most of these intertransition or transition metals are going to have multiple oxidation states. A few exceptions could be silver, which has a +1 oxidation state, and zinc, which only has a +2 oxidation state. Copper, on the other hand, which in our example here, has 2 oxidation states, +1 and +2. So whenever you're given a compound with a multivalent metal, you have to figure out which oxidation state it has. So here, I'm going to look at my anion, chloride. Chloride's in group 7, and therefore I know it has a -1 oxidation state. So because I only have one chloride and one copper, I know my copper has to have an oxidation state that will cancel out with my -1. In this case, it would be +1. The rule for naming ionic compounds with multivalent metals is you have to use a Roman numeral for the oxidation state of your multivalent metal. So in this case, because I have a +1 oxidation state on copper, the name would be copper, Roman numeral 1 in parentheses, chloride. Now, other Roman numerals that you may run into are 1, 2, 3, 4 is IV, 5 is V, 6, and generally 6 is about as high as you'll go. So here I'm given two examples, iron 2 oxide and iron 3 oxide. So what you have to know about multivalent metals in the names is that the Roman numerals give you the oxidation state of your metal. So in this case, I have a +2 oxidation state for my first iron, and I have a +3 oxidation state for my second iron. So iron, for the first one, has a +2 oxidation state. My oxide for the first one has a -2 oxidation state, and therefore my formula would be FeO. So this is iron 2 oxide. Oxide in my second one, again, has a -2 oxidation state, so I know my iron is +3 and my oxide is -2. So I need my overall compound formula to be neutral in charge. So I'm going to take the least common multiple of 2 and 3, which is 6, and I know I need a total charge of +6 and -6. So in order to get +6 as my charge, I know I need 2 irons with a +3 oxidation state. 3 + 3 is +6. In order to get -6 for my negative charge, I need 3 oxides. -2 times 3 is -6. So notice now, if I put 2 irons together, Fe2, and 3 oxides, O3, I now have a neutral compound. And this is iron 3 oxide.